Welcome back, learners. Now jumping to our application questions, and they are still based on electric cells. The first question under application question, it says that we have a guy called Clifford who makes an electric cell by placing a copper plate in a glass beaker with a copper sulfate solution, and a zinc plate that's also placed in a beaker with a zinc sulfate solution. So we have a zinc sulfate solution. So this guy is making an electric cell, and he has two beakers. On beaker A, he has a copper plate that is inside a solution, and this solution is called your copper sulfate solution. Then in another beaker, which is beaker B, he has a zinc plate, and in this beaker there is a solution, and that solution is your zinc sulfate solution. Furthermore, this guy now, he connects the two plates with electric conducting wires and a voltmeter. So after having placed the two metals into the two different beakers, he connects the two plates with an electric conducting wire and also a voltmeter. Furthermore, he completes the circuit by placing the two ends of the salt bridge in the two respective beakers. So this guy does all of these three things, and now we are asked, we need to make a complete drawing with captions of the electric cell. So this guy has beaker A, this guy has beaker A, let's label it there, and then there's beaker B. And on these two beakers, what does he do? He places a copper plate onto one, and then he places a zinc plate onto the other one. And then in this beaker, there is a solution, and there's also another solution here in this beaker. And then he connects the two plates with electric conducting wires, with an electric conducting wire and a voltmeter. So these two plates are going to be connected by the conducting wire, and then there's going to be a voltmeter in between it there. And then lastly, he completes the circuit by placing the two ends of the salt bridge in the two respective beakers. Then he is also going to put in a salt bridge that is going to be connecting the two respective wires. So it's just a simple a diagram. And now what we need to do, we need to now label the diagram. Remember, this is your electrode. And then this is your electrode. That's also another electrode. The two metal plates are your electrodes. And then the solution that we're finding inside, it is our electrolyte. Remember, this solution is used to conduct electricity. Then also on this other beaker, we're finding the very same thing, which is our electrolyte. Now remember, our electrolytes are different because the electrolyte that we find on each of these two beakers needs to have a relationship with the electrode that it's dipped into. If we are dipping a copper plate onto this solution, the solution must be a zinc, it must be a copper sulfate in this case. And then if we are dipping a zinc electrode onto this solution, then our solution must be a zinc sulfate solution. So the electrolyte must always contain the metal that makes up an electrode. So we can swap the two electrolytes on these two beakers. And then we have also this bridge that is connecting the two beakers, and this is called your salt bridge. And what else? This is your voltmeter. This is used to measure the potential difference of this entire electric cell. Now, I think we have labeled everything that we can label on this question. Now we're going to move on to the next question. Now, they are asking now, still based on Clifford and his little experiment, they're asking now, what are the zinc and the copper plates called? Now remember, those are the metal plates that are dipped into the solution of either the zinc sulfate or the copper sulfate. Now those metal plates, they are acting as electrodes. We have a positive electrode and a negative electrode, but both of them, they are acting as electrodes. They are acting as electrodes, or rather they are called electrodes. Then question 3, still referring to Clifford and his little experiment of a battery, we are asked that which substances in the cell acts as an electrolyte. Remember, this is a solution or a paste that is used to conduct electricity. In this case, we had two beakers, and these two beakers each had different electrolytes. Beaker A, the one that had a copper metal or a copper electrode, had a copper sulfate as an electrolyte. So we had a copper sulfate, and the other beaker, which was beaker B, had a zinc electrode or a zinc metal plate that was dipped in there, and the solution that we found there was our zinc sulfate. So we had a copper sulfate and a zinc sulfate. This is C, this is zinc. So those two solutions, they acted, or they were used to conduct the electricity from beaker A, from one beaker to the other beaker, because the electrons had to move from one electrode through the wire to the other electrode on the other side of the beaker. Now, with that said, we can move on to the next question, and whereby we are asked that initially the voltmeter reading is 1,1 V, which is 1,1 volts. Still now referring to Clifford and his electric cell. So initially the voltmeter reading was 1,1 volts, but it decreased gradually to below 1, and then from there it went to below 0.5 volts, and then until the reading was 0. So the initial reading of this voltmeter when it was connected, it was 1,1 volts. Then gradually it decreases to a number that is below 1 volts, and then further decrease to 0.5 volts or below 0.5 volts until it reached 0. Now question is, what is happening to the cell and why is this happening? We can now see that the cell, it is going flat. So the cell, because it is starting from a number going to 0. So now once the voltmeter reading reads 0, or once the voltmeter reads 0, it means that the cell or the battery, depending on how many cells you have connected, it means that it is flat because it is registering or reading 0. So the cell is going flat. Now, why is this happening? Remember, inside the cell we have a paste, we have a chemical reaction we have chemicals rather that we are finding inside each cell. So if those chemicals are getting used up, so they are gradually depleted. If they are gradually depleted, the battery will eventually read a voltmeter or the voltage of 0. So in other words, why is this happening? The chemicals inside the cell are depleted, or we can say they're getting depleted. They are getting used up. As it decreases, they are getting used up until they depleted. Hence, the reading is 0 volts. hence the reading is 0 volts. So the reason why the voltage is decreasing from 1,1 to 1 to below 0.5, because those chemicals inside that cell are getting used up, and then they are going to eventually get used up. All of them, they're going to get depleted, and once they're all depleted, the reading is going to be 0. Right. With all of that said, I hope we can then be able to answer certain questions that are still based on the electric circuit, the electric cells. Either we can you can answer the practice questions or even the application questions on your own. But then before we move on, we're just going to quickly go for a short break, and I will see you just after this.